Okay, so today we talked about quadratics and how to graph them and find their vertex and axis of symmetry, all without a calculator. So the very first thing is a quadratic. You need to remember what that shape looks like when we graph it, and it's a parabola. So all of these graphs should look like a U, which is the parabola shape. And right now they're going to be in standard form, which is y equals ax squared plus bx plus c. So this is the form we're going to be using. So then you're going to have a graph, and then in order to find that vertex, I'm going to do negative b over 2a. I'm getting the b and the a from this equation over here. And then once I find that, I'm going to plug it back in. So this would be plugging this, whatever this value is, back into this function. Okay. The axis of symmetry. So if we think about what symmetry means, it is a line where if I have it right here, it's going to be a mirror image on both sides. So this is our axis of symmetry, so that we know how to reflect a point over to get another point, so our parabola will be correct. Okay, so when we have a maximum, that means our graph opens down, so like this. And that's when your a value is positive. So if I go back to here, not positive, sorry, negative. That's my mistake. When your a value is negative, go back over here, and if this first term is negative, it's going to open down. So you're going to have an upside down parabola. Okay. If there's a minimum, that means it opens up, and this is where a is positive. So if our a is positive, there's no negative sign in front of it, then your parabola will open up, there will be a minimum value, and it's going to be a positive value. Okay. The y-intercept is 0, c. Remember, whenever it crosses the y-axis, your x value is always 0. And then c we're getting again from this equation. Okay, domain and range. Domain is dealing with the x values, range is dealing with the y values. So we need to graph it before we can write what the domain and range are. So there's all of that information. So now going back to this first equation, I have f of x equals 1/2 x squared plus x plus 3. So my a is 1/2, b is 1, c is 3. So the very first thing that we need to do is figure out what negative b over 2a is. So I'm going to have negative 1, because that's what my b is. My b is 1 over 2 times 1/2, because my a is 1/2. Plug it in. I have negative 1. 2 times 1/2 is 1, so I get negative 1. Alright, that's the x value of this vertex. So I'm going to have negative 1 here. Now, what this implies is I need to take negative 1 and plug it back into my original function. So if I have f of negative 1. So I'm going to have 1/2 times negative 1 squared plus negative 1 plus 3. This is where you need to use PEMDAS, and I would prefer that you not use calculators, because you will have all of this portion will be in no calculator on your test. So negative 1 squared is positive 1. Positive 1 times 1/2 is 1/2. And then I have plus the negative 1, so minus 1 plus 3. Once we get here, you're just going to go left or right. So 1/2 minus 1 is negative 1/2. Then negative 1/2 plus 3 is 2.5. And I went ahead and wrote it as a decimal, because that's easier to see in graph. Alright, so there's our vertex. So that's going to be our minimum or maximum depending on how this graph will open. So our axis of symmetry is x equals negative 1. So I'm just taking this negative b over 2a value that I already found, and that's going to be my line that it's going to be symmetrical about. So min or max. Well, let's go look and see what our a is. Our a is a positive 1/2. So over here, if a is positive, it opens up, which means it's a minimum. And then I want to know what that minimum value is. So the minimum value is going to be the y value of your vertex. So it's a minimum at 2.5. Okay. Then the y-intercept would be 0, 3. Because if we look, our c value is 3. So this is what our y-intercept will be. Okay, and then in order to do the domain and range, I need to graph first. So let's graph everything we know. We know the vertex is negative 1, 2.5. So there's that value. I know that there's an axis of symmetry at -1, so I'm just going to put a dashed line. Okay, that tells us where we're going to have our reflection about. I have the y-intercept at 0, 3. Okay, and then to get the other point, I'm going to use the axis of symmetry and reflect the y-intercept. So I'm going to go, here's my y-intercept, I'm going to use this axis of symmetry. It's symmetrical on both sides, so if this is here, this one would be here. Okay, and that way now I can draw the shape of it. So there's my parabola. Okay, so now domain and range. If I look at my left and right arms, they're going, this one's going to the left, this one's going to the right. So my domain is going to be all real numbers. My range, if I look, there's not an arm going down, so it's not negative infinity, but if I look here, this is my minimum value, which we already discovered, so it's 2.5, and then these arms are going to continue going up. So 2.5 to infinity. Or you can write it as y is greater than or equal to 2.5. Okay, so there's that. Hopefully by now you're understanding what domain and range are. Alright, so let's look at the second example. And the way you need to start with this is doing negative b over 2a again. So I'm going to have negative 2 over 2 times negative 1/4. So this is negative 2 over negative 1/2. Okay, remember when you divide by a fraction, you flip the second and multiply. So if I flip negative 1/2, it becomes negative 2 over 1. So now you have negative 2 times negative 2, which is positive 4. So there's the x value of the vertex. Okay, once you have that x value, take it, plug it back in. Okay, now order of operations, 4 squared is 16 plus 8 minus 3. Okay, then I need to take negative 1/4 times 16. Well, if I ignore that negative right now, a fourth of 16 is 4, put the negative back on, so this is negative 4. Okay, now we need to go left to right. So negative 4 plus 8 is 4, and then 4 minus 3 is 1. So there's the y value of the vertex. Alright, so now the axis of symmetry is x equals 4. If we look at our a value, it's negative 1/4, so it's a negative. So it opens down, which means it has a maximum value, and the maximum value is at 1, because that's going to be this point right here. Our y-intercept is at 0, c is negative 3, so 0, negative 3, and then a domain and range we can get after we graph it. Alright, the reason this one doesn't have any axes is because on your homework there are some y-intercepts or points that are going to fall off of this 10 by 10 grid. So I went ahead and made it to where you could create your own axes so that you have enough room. So I'm just going to, in this case I don't have any large numbers, so I'm just going to draw my lines. It really doesn't matter where. Okay, I'm going to plot everything I know. So I know I have a vertex at 4, 1 with my axis of symmetry. I know I have y-intercept at 0, negative 3. And again, with this point, to get the other point, I'm going to use this axis of symmetry and reflect this across. So there's that. So now I can have the shape of my parabola. Okay. So now, domain and range. The domain, again, I have an arm going to the left and I have an arm going to the right. So all real numbers. Range, I have arms going down, so it's negative infinity, and then we come to a stop right here, and the y value to this is 1. So it's negative infinity to 1. Or you can write y less than or equal to 1. Those mean the same thing. Alright, so this is what your homework's going to be based off of. You have 8 problems like this in the same table format, so you can get the idea and figure out how to go from there. Alright, if you have any questions, please come see me during tutorials, and good luck.